Today we're going to be working on modeling the addition of integers. We're going to start with this problem of the day. It's a review of percent of change. It's actually question number 1. There were 24 boys and 20 girls in a chess club last year. This year, the number of boys increased by 25%, but the number of girls decreased by 10%. Was there an increase or decrease in the overall membership? Find the overall percent of change in membership of the club. Go ahead and pause me, work this out, and then come back for checking. All right, well, let's start with the boys first. The boys increased by 25%, and there had been 24 boys. So if I set up my proportion, I'm not sure how many it was increased by quite yet. There were 24 boys, and that's an increase of 25%. When I work that out, I will find out that there are going to be 6 more boys on the chess club, in the chess club. Let's do the girls. Same deal. I'm not sure exactly how many girls were decreased, but I know that there had been 20. The decrease was 10%. When I work this out, I will find that we are going to lose 2 girls. So if we add 6 boys and lose 2 girls, it looks like there's an overall increase in the chess club. So to figure out my overall percent of change, I'm going to take those 4 kids over the 44 original kids. I got 44 original kids by taking 24 plus 20. And I want to know what percent that is over 100. When I solve that and I round to the nearest whole percent, there has been a 9% increase in the chess club membership. Your learning target today is that I can model integer addition using a number line. All right, so we're going to use the next few slides to help fill in the blanks on your handout. Then you're going to glue it into your notebook on pages 88 and 89. So we're going to start here with completing the steps to find the sum of -2 plus 3. We're going to fill in our blanks. We're going to model the equation using straight arrows called vectors on the number line below. All right, so when we go ahead and model addition on a number line, we always start with the tail of our first arrow on the integer 0. So we're going to start at 0. Because I have a -2, I want to move to the left. So I want to draw the vector or my arrow 2 units to the left of 0. This represents my -2. I'm going to stop with the head of the arrow on -2. The direction of the arrow is to the left since you are counting down from 0. Now I'm going to start my next arrow at the end of the first arrow or at -2. So I'm going to start at this -2 mark. I'm going to draw the second arrow 3 units to the right since I'm counting up from -2. So I'm going to count up 1, 2, 3 and end the arrow at 1. Let's try this again for the expression 3 plus -2. So we always start our vector at 0. Because my number is positive, I'm going to count to the right. 1, 2, 3, stop my arrow. Start where I stopped and move back 2 spaces, 1, 2, and my answer is 1. So it looks like the sum of -2 plus 3 and 3 plus -2 is the same. Order does not matter when you're adding numbers. There's a math property called the commutative property that says that I can add in any order that I would like. Suppose you received $10 from your grandmother for your birthday. You spent $4 on snacks. Using addition, how would you write an equation to represent this situation? Then, how would you model your equation on a number line to show your answer? Why don't you try this on your own? Go ahead and pause. When you're ready to check, come back with me. All right, so we're going to start our first vector at 0 as always, and we're going to receive $10. So we're going to move to the right 10 spaces. This vector represents the money you received from Grandma. Our second vector starts where our first vector ended, and we're going to spend $4. So spending $4 will move us left. 1, 2, 3, $4. Our answer is $6. So here's our addition equation. We added 10 plus a negative 4, and we ended up with $6 left from Grandma's money. Time to journal in your notebook. Tell me, what is the relationship between the length of the arrow on your model and absolute value? Pause me, take some time to journal, and then come back to check. The relationship between the length of an arrow and the absolute value is that those should be equal to each other. When you are drawing your vector, the length of your arrow should be the absolute value of the number. It's simply the direction that will change based on the sign of the number. All right, you are practicing at this point. Create a number line model in your notebook to represent -6 plus 4. Remember, you're going to start at 0. You're going to move to the left 6 spaces, turn around and move to the right 4 spaces, and find your answer. Come back and check when you're ready. All right, I'm going to go ahead and make my vectors under my number line this time. I have a little bit of more space down there. I'm going to start at 0, and I'm going to count down: -1, -2, -3, -4, -5, -6. There's my first vector representing that integer. I'm going to start where I ended, and because it's a positive 4, I'm going to move ahead 1, 2, 3, 4 spaces. My second vector represented that integer. My answer is -2. Please do the same thing. Pause here, create the number line model, and come back and check. As always, we're going to start our first vector at 0. We are working with a positive 3, so I'm going to move ahead 1, 2, 3 for my first vector. My second vector is going to represent a -8. I'm a little short on space, so I'm going to come down here and move back 1, 2, 3, 4, 5, 6, 7, 8, and stop at -5. My answer is -5. So you've been playing the integer game. That's the one where you're trying really hard to have a sum of 0 or be as close to 0 as possible. Thinking about that game, let's model the addition of your 3 cards. Let's pretend you have a 5, a -2, and a 3 in your hand. So we would start at 0. We're going to model 5, moving to the right 1, 2, 3, 4, 5. That's our first vector. Then we're going to move back -2, 1, 2. That's our second vector. And finally, we're going to turn around and go 3 ahead. 1, 2, 3. Notice I have 3 vectors because I had 3 integers. I ended at 6. My answer to 5 plus a -2 plus 3 equals 6. Now earlier we found that the sum would not change if we changed the order in which we added the numbers based on the commutative property that says I can add in any order. I'm not sure there's an advantage to changing the order of the numbers we're adding. Some people like to add all their positives first, so you would add 5 plus 3, you'd get up to 8, and then you'd back it up 2. But that's totally a personal preference. All right, it's time to play the integer game with your group. You will be recording your equation, number line model, and solution in your notebook at the end of the game. And here's your exit ticket. Please make sure that you answer all 3 questions, put your name on your paper, and turn it in.